when I compare with a datagram and virtual circuit. So this is the third approach where we are going to be using a switching. So where it combines both the virtual, and it never uses neither the virtual or nor the conventional datagram. That we call it as a source routing. So this is the third approach. As the name itself implicable, here all the information about the network topology that is required to switch a packet across the network. As the name implicating, it is a source, right? So here this topology is required to switch a packet across the network. So the information will be provided basically by the source host. See, there are the various ways of implementing this source routing. So basically, I just am explaining what it is, then we will go with the discussion of our source routing. So before we are going to be implement it, so mainly first thing you should understand, it is neither virtual nor conventional. So as the name implicates, to switch a packet across the network, so the entire basic information will be provided by your source code. That's why we call this as a source routing. So let me start with the first the implementing. Once would be assigning a number to each output of each switch. The number will be assigned and that number should be placed in the header of the package. Here the number will not the addresses, the number will be assigned for each output of the switch and that number will be placed in the header of the packet. So here the switching function. Now as we discussed the datagram and virtual switching function, so this switching function is very simple. So for each packet what it will do, whatever the packet that will arrive an input, the switch would read that port number, because here we are fixing a port number or assigning a number to each switch, right? So that port number in the header, we are already transferring the header and transmit the packet on that output. So whatever the switch would read the port number, so in the header, and that based on that information, the packet will be transferred on that output. So however, since there will be in general more, if we are having a more than one switch in the path between the sending and the receiving. So basically this is including only for one switch. So basically if we have a more number of switch between the sending and the receiving host, so how these will be implemented? Here the header of the packet need to contain enough information. For one switch, one port number, it will be storing in the header. If I consist of 3 switches, all the 3 switches information should be stored in because it has to determine, right, which output the packet needs to be placed on. So let's take how this will be working. If my circuit consists of more than one switch. So here is basically an example where we are working. So one way to implement this is for the single switch. So one way to implement this is an example. So you can see here the order list of switch ports in the header. So as being stored in a form of a row table. This is the switch 1 where we have stored the order. Now I want to communicate from host A to host B. Host B is being connected from switch 1 through the intermediate, that is a switch 2. Switch 2 has a connection to switch 1 as well as switch 3. I need to transfer the packet from switch host A to host B with the help of switch 2. Right. So these ports information 301, because we are having a more than one switches, right? These lists will be maintained in the header 301. Once it will be transferred, right? So this list will be rotated when it transferred to the next switch, okay? This is always in front of the list. So in this example, let's take, just to make you clear, let's take this step by step. Now the packet I need to transfer from host A to host B, it needs to traverse through the 3 switches here. Switch 1, switch 2 and switch 3, right? So switch 1 needs to exist from which port? Port 1. You can observe here, this is a number where port 1 has been connected to switch 2. So what? 3, right? And similarly, the switch 2 need to exit from the port 0. It will be connected to switch 0 of switch 3. Again, the switch 3 exits from the port 3 to connect to an host B. This is the meaning of the first point. It is the exist port number of a switch 1. What is the exit port number of switch 2? That is a 0. What is the exit port number of switch 3? That is on port 3. So thus the original header when the packet this is a packet, right? When it leaves the host A, it contains the list of the ports called 301. So where we assume that each switch reads the rightmost element in the list. So this is the rightmost elements these are the elements in the list where preferably it will be follow the rightmost element of the list. See, to make sure that like next switch gets the appropriate information. So as I said, when your packet start moving from one switch to another switch, it will rotate the list. That is what the significance you should understood. It will rotate the list after it has read its own entry. Once the switch read its own entry, it has to rotate the list. So the packet where it will start one, right? From one it will en route to switch 2. Now the packet previously what we are having 301. Now once it will be rotated, the one already is root out, right? Now what happens? The one will be moved to the corner. So 30 remains same. Again it will be root out to where? 0. So again you can see here. So 0 left here, 1 and 3 comes to this side. So after every transmission the switch will rotating. So switch will enroll. So switch 2 will perform rotation. Again switch 2 sends the packet, that is 013 in the header. So although not shown, so again switch 3 performs another rotation, right? Restoring the header. So because when host A is sent. So this is what the basically how the source routing works. So this is what the meaning of source routing. So the source routing is neither a datagram nor an conventional. So that is a virtual. So what we are going to do, each node is puts a number, right? When more than one switches are there, so every switch outgoing port number will be added in, and so the header. So these header, when it travels from one switch to another switch, it takes this particular packet, then it will be it will perform a rotation of the switch rotation on the list. So when the switch rotation perform, obviously the order of the packet, the sense of the packet order in the header is changed. Okay, so every switch perform its rotation. So basically we have several things to notice about this feature. So when we going to notice some of the features, first, so we are transferring a packet from host A to host B, right? It assumes that host A knows enough about the topology of the network. Topology in the sense like how many switches, how many hosts has been connected to the network. Entire information from header, what are the right direction, every switch in the path. All information, it assumes that it knows it. But somehow if you take about in analogous to the problem of building the forwarding table in a datagram or figuring out where to set up a packet in a virtual. So basically in a datagram what we were doing, we were creating in a forwarding table. So whereas in a virtual, so we are setting in a virtual circuit, right? We are creating in a VCA table. So these are the two approaches, these are the analogies. But here in practice if you see here, first switch at the ingress to the network. What do you mean by that? As opposite to the end host is connected to that particular switch that appends the source route. So this is the first observation. If you go to the second observation, that we cannot predict how big the header needs to be, the length of the header, since it must be able to hold one word of information. So every switch on the path, so we cannot predict that. What is the length of your header? How big my header is going to be continued. So this implies that probably what type of headers is having a variable length. There are no upper bound, or we cannot predict absolutely the maximum number of switches through a network need to pass. The third, the problem. So there are some variations on this approach. For example, every switch travels, we used to go to the rotate the header. Each switch could just skip the first element as it uses. So once the first switch uses this outer interface as we can skip right. So rotation has an advantage over stripping. So let's in depth I'll explain you what is the stripping in the next slide. See, host B gets a copy whatever it is having original, right? So it may able to figure it out how to we can go back to an O state. So that is what instead of rotation as an advantage over the stripping, at another alternative we can make use of a pointer by for carrying a header to the current, means what is the next port entry. We can make use of the pointer just to update in a header switch tables. So this pointer rather than use as in a rotating the header, this will be more efficient to implement. So these entries, right, the switch needs to read is A. What is the next entry in the table? So this will be easy for us to make. Now basically here I'll go with the discussion. Now, this is an example where we have taken. So, you can observe there are the three ways to handle an error. The three ways are, so like header, if we can observe here, this is another format. These are the header entering switch. Like a 301 as I taken, just here we named with an alphabet called A, B, C, D. This is what the first switch entry where we have, right? So this is the, like when it moves to, but if you see this is the source routing. Once this is what the header, it consists of an switches. Let's assume here the 4 switches I am using. These are the information stored in my header part, switch header part. Once it's to move to the next switch, header leaving the next switch, what it will do, it will perform a rotation. Now A comes here after rotating. You can see the rest of the things remain same. This is what a source rotation we are performing. Now if you go to the next method, what is the next method? We have stripping, as I mentioned. Stripping in the sense, see, already your header entering the switch. So this is the first switch entering point, right? Where I can strip this, I can strip out this rotation, means it has a backup data. So if we strip also, it doesn't make any difference. Another method, we are making use of a pointer here. So here the pointer makes you the easiest way. First I am making a header entering switch. See, once the switch is moved to the next switch, right? You can observe the pointer has been shifted to the next header. So these are the labels where we are reading from right to left. So these source routing algorithm. So it can be used both in an datagram as well as virtual circuit if you implement any like stripping or any pointer. So for example, I can give IP protocol, that is an internet protocol, which is a datagram protocol. So this includes an source root option, because why we need a source root option there? So I can allow the selected packets to root at the source. So because majority are switched as conventional datagrams. So source routing is also used in some virtual circuit networks as the means to get the initial setup request along the path from source to destination. So that is the reason, as I mentioned. So it could be used as a datagram, it could be used as a virtual circuit, and even sometimes it will be categorized as strict or loose. So what do you mean by strict source route? Every node along the path must be specified. Whereas the loose source route only some specific set of a node to be traversed without saying exactly how to get from node to next. So there is a lack of information. That is what the meaning strict or loose. So even the loose source route can be taught as a set of a waypoints rather than making it completely specified route. So the loose option, so these especially the loose option can be helpful to limit the amount of information on the network. So the source must obtain to create a source route in any reasonable, especially in a large network. It is likely to be hard for a host to get the complete path information, because it needs to construct correct and stick the source route to any destination. So this is the significance, why it is required. So what is the source routing? How we will be handling? So it could be used either in a datagram or it could be used in either in a virtual circuit network. So these are the examples as I mentioned. So thank you.